first speaker tonight, here to talk about prehistoric ecology, Brian Eng.
What's up, y'all? Just so I can gauge where the audience is at, because I know we got space flight travelers in here, we got historical princesses, and I think there might be a fair contingent of people who are here because they're about that prehistoric piece like for real. Can I get a roll?
So, my talk is about dinosaur stuff, but before I fully get into, you know, the site that I'm going to discuss, I was wondering does anybody here know what you do if you find an awesome fossil? Does anybody? Keep it. Any other ridiculous suggestions? eBay. All right, so we've got. Don't let Cope get it. All right, so exactly, we got some capitalism in the house. That's all right. Don't do any of that shit. Chances are, more often than not, the fossils you find are on public land. And so I'm going to give you a real quick crash course on what you do if you find a fossil. Step one, don't remove it. If you, in the case of like a dinosaur footprint like this, it'd be really goddamn hard to remove anyway, but that doesn't stop people. People still try and chisel dinosaur footprints out of big beds of rock and completely destroy them in the process. The first step you want to do is document it. Take a picture of it and put something in the frame so you can tell what size it is. So here I've got a scale bar. The Bureau of Land Management, BLM offices actually give these out for free. But I mean, I've also got my foot in there because it gives you like a human sense of scale. This is a big goddamn footprint, and that's significant. When you show that to somebody in the in the field of paleontology, they'll go, "Oh shit, that's a big goddamn footprint." So that's important to have. You gotta have a sense of scale. Step two is you want to figure out where the fuck you're at. Now, that can be as simple as dropping a waypoint on your phone, GPS in it. The other thing you can do is draw a treasure map like a pirate if you don't have your phone with you. Now, if you're off trail exploring the desert wilderness and you don't have a phone to take a picture with, I just want to say I hope the shit you're on is good and that your spirit quest goes well and that the fossil is real. But you should still try and document what you found as best you can. So you want to take that information and then you want to alert whatever the land authority is for the public land that you're on, whether it's you could be on national forest land, state park land, national park land, all of which you just go to the visitor center and you'd be like, hey, I found a fucking big ass footprint or whatever it is. Who do I talk to? And they'll point you in the right direction. Now the reason that we do this isn't just because I want to like crush your hopes and dreams of having a fat dinosaur bone on the mantle, but because we want to keep it in geologic context. Now this is really important because a lot of times what will happen if you report the fossil to science essentially is you might end up going on a hike with like this lady if you're in eastern Utah, for example. This is Rebecca Hunt Foster. She's a BLM paleontologist for the Moab Canyonlands District. It's stupid how much fossils there are out there. I am an idiot who's only been out in the field a few times, and I've found like significant chunks of dinosaur bones and stuff like that. So we want to keep it in geologic context, and often if you, you can turn over like your waypoint and your photo and your treasure map, and they'll go, okay, well, check this out. Or in some cases, you actually go out with a paleontologist, and they may give you the awesome experience of explaining what the geologic context of the thing you found is. And that can also sometimes lead to new discoveries. Paleontologists will often look and go, oh, that little piece of bone you found, there's another one like it over there, and then they'll follow this crumble of bone to where the actual skeleton is eroding out of the cliff face or rock formation that water has cut through like the layers of time to expose this bone. The other thing that can happen is when you bring that piece of the larger story of life into the realm of science, you've added a little bit to that story and you actually increase the available public knowledge and educational resources. All of what I just described happened with the site that I'm about to talk about. This is the Mill Canyon Dinosaur Track site, just outside of Moab, Utah. A hiker was walking along. He found some few dinosaur footprints. this is John Foster, Rebecca's husband. They're both paleontologists, and they're fucking unstoppable as a couple. It's insane, and it's awesome. Anyway, when the paleontologists when they went out to the site to check it out, they're like, oh, this layer with footprints in it continues under all this other sediment. And so they started excavating it, and they excavated it, and they kept on excavating it for, I think it was a multi-year, largely volunteer effort from the local Moab community. As you can see, we got kids and just regular people, and a team of paleontologists came out and studied it, and they uncovered this massive track surface that is just, it's ridiculous how many different animals there are in it. So ridiculous, in fact, that there's no fucking way I'm going to be able to tell you all the things I want to tell you about this track site in the time that I have allotted. This is an international team of paleontologists who came to study the tracks here. And this is what it's been developed into. Thanks to the Respect and Protect initiative by the BLM and Utah Friends of Paleontology, they've developed it into this public fossil site. It's like an outdoor museum exhibit. You can walk around these boardwalks, which allow you to get close up to the fossils and you could like reach over and take a totally high-res close-up picture. You can see these fossils in incredible detail, and there's interpretive signage all the way around it explaining what you're looking at. I was brought in, I didn't introduce myself at all. I'm Branding, I'm a paleoartist. That means I work with paleontologists to reconstruct ancient animals and their environments. I was brought in to do this illustration, which we're censoring with the shoulder of a paleontologist to tease you guys. You gotta sit through the whole talk before you get the money shot. So, oh my. So what I did is I went out to the site, and the concept that Rebecca came to the project with was that we want the illustration to match what's in front of it. So here you can see the site before all the boardwalks were installed, and we've got Rebecca's husband John here and their little daughter Ruby pacing out the trackway in front of my camera, so I can create this photo panorama with some of the better preserved tracks mapped out on it. And this is basically like the foundation of the entire illustration. So in order to figure out, what animals made these tracks is a little bit difficult, because this whole environment that we have here was a lakeshore that was part of a larger geologic layer that preserves like a desert environment. And while it preserves, like this whole area is just trampled with tracks. But this layer doesn't preserve any bones. If you leave an animal carcass out in the desert for a long time, it just like weathers and bakes in the sun and crumbles apart. If you guys want to get fossilized, make sure you die somewhere where your body is buried in an anoxic sedimentary environment immediately after you die. Die while, die in a lagoon or something. Get covered in limestone, it'll be good. So in order to figure out what these animals should look like, we have to look at the broader geologic context. So what we have here, this is called a stratigraphic column. It's basically a diagram showing all the distinct layers of stone or sediment in this large system of rocks called the Cedar Mountain Formation. So that lakeshore is part of a lake deposit that's in the Cedar Mountain Formation, and it's in a section of the Cedar Mountain Formation called the Ruby Ranch Member. And what that means basically is like each one of these sections kind of records a distinct environment or a depositional environment or conditions that were laying down sediment in a given place. Now this is important because what you'll notice is here in the Ruby Ranch Member, you look on this side of the column, we got bones where we found dinosaurs. Now Ruby Ranch, we got one incomplete skeleton up there. This column actually is only for a few sites. There's a bunch of stuff found from above the Ruby Ranch, and there's a bunch of stuff found from below the Ruby Ranch. Over here, we have pretty much like everything that's ever been found in the Ruby Ranch Member of the Cedar Mountain Formation. It's not very much. We've got some teeth, some chunks of armor, a few toe bones, not complete animals. So this makes my job a little bit difficult reconstructing what these things look like. But fortunately, there's enough here that we can look above and below in the stratigraphic column and get a better picture of what's going on in North America.
So when we look at all the rocks of that age, we get a very different picture of North America. As you see, us here in California, the land we're standing on, the rock that we're on, it's not there yet. It's under the ocean still. So it's either oceanic sediments that get pushed up later, or it's islands out at sea that get dragged into the continent. Because what's happening here is the Pacific plate is mashing into the North American plate. It's pushing up these mountains. And the reason those mountains are important is because they're creating what's called a rain shadow effect. The rain shadow is actually happening right now. I scheduled the weather perfectly for this. As our weather is coming in off the Pacific, it hits the mountain ranges, it gets pushed up. As it goes up in elevation, it cools, it dumps its snow and rain on the mountain. And what do we have in California on the other side of like the San Gabriels and the Sierra? A desert, right? We got the Mojave Desert. Same thing was happening at this time in Utah as Nevada was just getting ripped by this impact of this tectonic plate. Now, our lake is here in east central Utah, in that foreland basin. And so it was this lake surrounded by a desert, fed by water running off of these nearby mountains. Now, the other reason why we got to look at the continent as a whole is because fortunately for me, and for us as a species understanding our planet, we do get good dinosaur fossils from the wetter areas surrounding this desert. You know, we've got water, area carcasses, and one of the things they tell us is that we had influxes of dinosaur families coming in from Asia and in from Europe. So we have this interesting transitional time in North America's ancient history with sea levels rising and falling and influxes of animals coming in from other continents. So let's meet the creatures. Perhaps the most abundant plant-eating dinosaur prints at the site are these huge three-toed footprints. The one at the beginning of my talk, you can see how big they are. They got blunt claws on the end, and that's because they're from a group of dinosaurs called the ornithopod dinosaurs. You can think of ornithopods kind of like huge, like 20 to 30 foot long in this case, scaly goat dragon birds. Really weird animals. The name ornithopod, ornitho means bird, pod means what was that?
Happy place.
Happy place? What's not happy about? What's not happy about beautiful animals that we've survived? We're in a happy place, okay, good. Gold dragon birds are definitely a happy place for me. I don't know. I wasn't sure. Something about the tone of voice threw me off. I was like, are you alright? There's some weird animals in deep time, yo. Anyway, these things had beaks on their mouth like a bird, but they had molars in the back of their jaw for grinding up tough plant material. That may have been how they were able to survive in this desert environment. And they had weird bird-like feet, even though they're on the other side of the dinosaur family tree, far away from birds. Another plant-eating dinosaur that left these goofy, fat-heeled footprints with 4 derpy toes is the armored dinosaurs. These are awesome. Yeah, feel free to more, right? All right, so what we have here, is a selection of armored dinosaurs from about the same age, a little older, and a little younger than our track site. What you can see is their bodies don't change that much. What's changing rapidly is their armor. And again, this may have to do with the fact that we've got new predators coming in from Europe and Asia driving this armor evolution. Now, this guy right here, his name is Dr. Jim Jim Kirkland. Oh, it's right there. Dr. Jim Carpenter. Ken Carpenter and Jim Kirkland advised heavily on this project. My brain is like trying to manage time and also say all the things about all the dinosaurs as fast as possible. He loves these monsters. He's discovered a number of them, described a bunch of them. He keeps publishing new family trees. And he has suggested that perhaps another thing that was driving the evolution of their armor was it may have played a role in intra-species recognition, display, and combat. In other words, just like modern antelopes and modern reptiles and birds will use weird protuberances on their body to show off to another and display to potential mates and also challenge rivals. These guys may have been doing the same thing. They may have been locking like their shoulder spines together and having shoving matches. Now, it's important to bear in mind that what we see here in the fossil record looks way lamer than the actual animal might have looked in life. These right here are just the bone core of the armor. Now, the bone core is exactly what it sounds like. It's the foundation to the armor. It's not the name of an awesome metal band that doesn't exist. Now, covering the bone core is something called the keratin sheath. This is important to know about because it can dramatically change the look and the function of these structures. Keratin is the same stuff that your hair and fingernails are made out of. It's also the stuff that covers birds' beaks, the horns of antelopes, and armor of things like these guys, turtles and crocodiles. And the cool thing about keratin is he any color you want, especially in birds. Birds figure out how to make all the colors in keratin. So we don't really know. What's that?
Start that vein instead.
Start that, which one? Keratin sheath. I also like that, so when a really exceptional specimen gets preserved with the bone core and the keratin sheath, it's in a geologic system that's lithifying. Lithification. So I gotta move fast, because we're like a third of the way into the dinosaur. We have these sauropod dinosaurs. Sauropods are those huge long-necked dinosaurs. Some sauropods evolved into the largest land animals that ever existed. And yet, at this site, the biggest prints we have, they're like a little bigger than an elephant footprint. And again, that may be because we're in this harsh desert environment that can't support supergiants like you get in more forested, lush environments. Some of the few bones we have of sauropods from the same, the Ruby Ranch, remember, the same section of the geologic record as our lake. We have some sauropods like Brontomeris here, and Brontomeris is cool because it's probably a titanosaur, which is one of those families coming in from Europe. So again, more evidence of influx from other places. One of the cool things about titanosaurs is that some of them also had bone core on them with keratin sheath. I guess keratin sheath is like the cover band for bone.
So we're going to step out of the herbivores and we're going to move up the food chain a notch into the omnivores. These gorgeously preserved prints, you can actually see in real life, you look at them up close, you can see every toe pad from the bottom of the foot preserved. And they match best with the foot morphology of these ornithomimid dinosaurs. This is Struthiomimus. It's a lot younger than our Trackway, but the basic body plan is pretty conserved. And it's next to an ostrich because it's another example of what we call convergent evolution. Both of these types of dinosaurs have evolved really elongated legs to make them faster and more efficient at running. Struthiomimus, however, it's kind of a funny name because it means ostrich mimic, and the group of these dinosaurs is called ornithomimids, which means bird mimics. But they evolved like over 100 million years before any of the ostrich family, the ratite birds, had even evolved. But it's a great example of convergent evolution. I just think they're like gorgeous looking animals. And so it's kind of cool to know that they were at the site. Now, can anybody think of another theropod dinosaur? So a dinosaur on that meat-eating dinosaur side of the family tree that's way overpopularized in pop culture, walking around on Velociraptor, right? It's walking around on 2 toes here. Now, Velociraptor is in a family of dinosaurs called dromaeosaurs. And dromaeosaurs had these gnarly ass sickle claws on their inner toe. And we have prints that indicate that this reconstruction showing them walking on 2 toes and holding 1 toe erect is accurate. We have these 2-toed prints. Now, this is the one thing about these dinosaurs that Jurassic Park got right. And you gotta give credit where credit is due, because when that movie was made, 2-toed footprints like that hadn't been discovered yet. That was based on the theory of a renowned paleontologist named John Ostrom. Rest in peace to the big homie. He described this creature, Deinonychus, which is a dromaeosaur closely related to Velociraptor. It's a North American relative. And now Velociraptor stands about this tall, so not as big as in the movies. Deinonychus stands about this tall. There were ones that got up to the size of the ones in the movies, but they look totally different otherwise. They had a much more narrow skull, kind of like a blade-like skull. They would have been completely covered in feathers. They actually have quill knobs on their ulna, just like flighted birds. So they had flight feathers, but they weren't flying. And so this has led scientists to propose that the basic wing architecture of birds evolved as a display feature. One of the other interesting things that's way different than Jurassic Park, I'm gonna have to put the mic down for a sec to demonstrate this, but they couldn't have bunny hands like a raptor. When they grabbed stuff, it was like this. Very scientific. So the reason that's important is because they share a common ancestor with birds, and that weird clapping kind of arm motion was how they caught their prey, and it's probably the same motion that later got adapted for flapping as they climbed up things or glided down from things, and then evolved into the flight stroke of modern birds. So again, Jurassic Park got a lot wrong, but you gotta give credit where credit is due. The two-toed footprint thing is pretty cool when a hypothesis is confirmed. Now we're gonna jump up another level in the food web. This is a print of an animal that's actually still, well, some representatives of this group are still alive today. So this isn't a dinosaur. This is a modern animal. Anybody want to guess what this is? A hint is that I photographed basically the same track or the same print at the Los Angeles Zoo a few days ago. It's a living reptile. Yeah, it's a crocodile slide. So you can actually imagine this is the belly of the crocodile sliding along. This is its back leg pushing off of the mud. And as the tail comes along, it cuts this deep, the tip of the tail cuts this deep furrow down into the mud. And it's like the same fucking trace at the LA Zoo the other day. I was like, oh, I'm putting that in my talk. Fuck yeah. So these were, I mean, they basically looked like modern crocodiles. This is Goniophilis. Its skull is a little bit different and the armor is a little bit different, but you and I would totally recognize it as a modern croc. Now we get into our grab bag theropods. We've got some stuff that would be higher than those crocs on the food web. These medium-sized theropod dinosaurs. But we don't really know exactly who left all of which prints, because the thing about the theropods is they all have that basic 3 toes with sharp claw design. Now those ornithopods, those plant eaters I showed you at the beginning, those don't have the sharp claws in their feet, and they're actually on the other side of the dinosaur family tree, and more convergent evolution is why they have the 3 toes. But we've got this, what I call a grab bag of theropods. The theropods have these 3 toes with sharp claws, and even birds, which evolved from, which are theropods, they have 3 toes with sharp claws. And so we've got everything from little things that have been interpreted as early shorebird type animals that are in the skeletal record from Asia from the same time period. We got these medium-sized things that could have been either one of these two. This guy is a super weirdo because this is the therizinosaur called Falcarius. It's got crazy claws on its hands. Its teeth are super reduced, so it's probably, and it's got this long neck, so it's probably going in kind of an omnivorous or herbivorous direction, kind of like what the ostrich dinosaur I showed you earlier was doing, but it's still kind of keeping the same scary ass old school theropod feet. So we could have had those there, but we wouldn't really be able to tell because the foot has kind of remained the same. This guy is kind of our upper level predator, but not nearly as gnarly as what left this print. This is the print of the apex predator in this ecology. And its foot would have looked something like this. Now, this skeleton is actually not the skeleton, this foot picture, I have to just disclaim to any paleontology buffs out there, this is actually the foot of a Tyrannosaurus Rex, which lived way, way after this, but the basic like toe and claw shape was all the same. Shout outs Thomas Holtz, who is probably he's a Tyrannosaur expert who might give me a hard time on Twitter if I didn't mention that. Tyrannosaurs have this uniquely compressed metatarsal condition called an arctometatarsalan condition, so an expert might give me a hard time for this, but otherwise the basic setup is the same. Sharp ass claws on the tip, big, powerful toes with big pads for absorbing all that weight. This wasn't a Tyrannosaur, though. It was another family of huge, terrifying theropod dinosaur. It was most likely Acrocanthosaurus, which lived at this time, and we have really complete skeletons from Texas, Oklahoma, and Montana. So that whole moister area surrounding our desert area that isn't preserving good bones. And if you think about the modern range of large predators, they will often, you'll often have like African lions living in savanna and marshland and mixed forest woodland. So it was probably this or something closely related to this. They've also found teeth in the actual Ruby Ranch member, like the same layer as the lake shore, and the teeth are really similar. But this is just a fucking badass animal. This dude here, Lawrence, is a friend of mine. He's about my size. He's a full-grown man. This isn't a little kid standing next to this thing, all right? And just imagine him going in that mouth. It wouldn't even tear him apart. It would just swallow him. He'd just go whoop into the gullet and just get digested with lacerations and lots of gastroliths grinding him up. The other, I mean, this is just, I could do a whole talk just about like the badassness of this animal. One of the things that is really unique about it though is that it's got these elongated vertebral spines down its back. You can feel your vertebral spines, the very tip of them. Now in humans, the longest ones are like, I don't know, maybe 2 inches, 2.5 inches at the most. This guy's vertebral spines are like the length of his torso. And the reason you can only feel the tip of your vertebral spines is because they're braided with muscle. They support your whole vertebral column. We don't know exactly why this thing had these crazy ass vertebral spines, but one thing that is pretty certain is that they would have also been braided in masses of muscle. So while it's been proposed that this like sail-like structure of the spine might have been for display purposes, but it almost certainly would have also given this animal incredible mechanical advantage when anchoring that saw blade face into a huge carcass and then S-curving its body like a Komodo dragon to drag its serrated teeth through the bone and flesh and just excavate masses of meat. This is a nasty little thing. One of the cool things about its trackway is it's one of the most continuous trackways. We've got like 17 steps in a row, but it's kind of funny because they're really close together. They're like this far apart, or maybe a little farther, but like that's an animal that's 6 feet high at the hip, so it's taking little careful steps through this slippery mud. One of the other cool things is that after it walked by, one of those sauropod long-necked dinosaurs stepped on one of its footprints, which is kind of cool. This might imply that this was kind of a high traffic area in the ecology. Now there's one animal in this ecology that I consider to be more badass even than Acrocanthosaurus, and it left these prints. Members of the same group of reptiles are still alive today, as evidenced by these prints in the modern desert. These animals are serious badasses and relentless, merciless, unfeeling predators, and they've survived multiple mass extinctions. And of course, those of you who know your shit know I'm talking about turtles. This is an Indo-Chinese box turtle just because I happen to have a picture of Indo-Chinese box turtles. And look at that face. He would eat you and not care for you at all. Turtles are really awesome, and I feel like I need to like point to this because seeing those tracks preserved in 112 million year old mud, it's kind of haunting to think that these things they've been around that long. They survived Acrocanthosaurus, and yet turtles now are actually kind of in trouble, which is maybe something more people should know about. These motherfuckers who can survive multiple mass extinctions, they can survive the extinction of the dinosaurs, their fossil record in some cases will just continue across a mass extinction where everything else goes and mass extinction happens, they all die. We don't see any more fossils from that animal. Turtles, in some cases, their fossil record will just continue like, oh, we don't give a fuck. We'll hibernate for a few months, wake up, eat some rotting carcasses and bugs and our own shit, we don't care, and then go back to sleep. Right? Turtles are unstoppable, and yet in modern times, this is one of the first times in a long history of turtles that they're actually kind of on the ropes. Turtle populations have been decimated due to overcollection for the pet trade, habitat destruction, degradation of water quality. I think this is something that we, as a species, we need to take note of, because if these motherfuckers, these gangster-ass motherfuckers right here, are having a hard time surviving, we need to put our own shit in check, because there's a lot of other species that we rely on for survival that don't have the track record that turtles have for surviving gnarly-ass shit. So, now that we've met the creatures, I'm still left trying to figure out what the rest of the environment should look like. These rocks wouldn't have been there. These are older rocks that have been pushed up by tectonic upheaval. So I spent a lot of time wandering around this lakeshore trying to figure out what the shape of the lakeshore was and looking for any traces of plant fossils. What is the basis of this food chain? What's nourishing all of these giant herbivorous animals? I didn't find shit, and it really bugged me, because it's like, I need to know what to paint over here and over here. Yeah, knowing where the dinosaurs is an unusual luxury that I don't normally enjoy.
A better picture of the environment didn't start to take shape until I got a hold of the geochemical analysis of this mud done by a geologist named Elizabeth Montgomery. Her geochemical analysis was awesome, because she basically took a sample of this rock that's basically liquefied mud, or mud that's gone through lithification.
And one of the things she identified was 2 modern lake environments that have a similar chemistry. And these were really interesting lakes. because they were alkaline. Now, have any of you been out to Mono Lake?
Yeah.
Okay, so have any of you been to Burning Man? All right, so Burning Man and Mono Lake, and Burning Man's dry now, but that's an alkaline lake bed. Water flows in, it carries minerals in from the surrounding mountains, and then evaporation dries up the water, leaves the minerals behind. This lake isn't as gnarly as like the Burning Man Lake or Mono Lake. Those ones are so alkaline and have so much gnarly minerals in them that they're super toxic, which is hilarious to me that y'all expose yourself to that voluntarily annually. That playa stuff is like, that's some gnarly shit. But anyway, this lake isn't nearly as alkaline as those ones. It's in this sweet spot where you actually get a proliferation of life at the inflow point of this lake. Now, in the far side of this lake, you can see it's a horrific desert wasteland that would be difficult to live in. But where the fresh water is flowing into that mineral concentrated water, it's creating this explosion of growth because that mineral saturated soil seems to be really good for growing these soft-bodied plants, and animals are aggregating around it. This is also the case with the other modern analog lake. This one is in China. It's called Bosten Lake. It's basically in like the deserts of Mongolia. You can see it's surrounded by sand dunes on this side. And again, where the inflow of fresh water hits that mineral-enriched soil, you have this explosion of plant growth. One of the cool things about Bosten Lake is that it's got all these soft-bodied water plants, including water lilies. Water lilies for me are very exciting because they are an early Cretaceous flowering plant. Flowering plant, yeah, right? Flowers, come on now. Those didn't exist for most of the periods of times that I have to do illustrations of. So I'm stuck painting ferns and redwood needles and stuff, which take a really long time to paint. Water lilies look nice, but it's also interesting because these soft-bodied water plants, they don't leave, when they die, they don't usually leave a good body fossil, like a trace of a leaf or a stem. They kind of just mulch down into just organic glorp. But water lilies left a good pollen record behind. Their pollen is pretty resilient, and they were globally distributed at the time that our lake was full of dinosaurs and getting prints laid down on it. So I had to include them. This is the final illustration, which incorporates all of those lines of evidence. So, we've got a whole bunch of details drawn from all those different lines of evidence. We've got this foreground sauropod here. He's actually calling to these ones in the distance, letting them know about this murder face over here that's just marauding around looking for the sick and weak to shred apart with its giant jaws. We've got our armored dinosaur here, mapped to the trackway of the actual armored dinosaur. We've got water lilies, crocodilians, birds, the whole deal. And this is actually out on the site where you can see it. Now, I feel like maybe like over in that corner somewhere, there's a handful of people who are like coalescing, like, I don't give a fuck about dinosaurs, dog. I came here for this metadata talk. This dude needs to hurry up. I feel y'all, it's cool. You can be into whatever you're into, but I want to give you guys a couple quick takeaways as to why I do this stuff and why I give a shit. Here's my takeaways, real quick, all right? I don't expect anybody to remember all the stuff about alkaline lakes and geochemistry and dinosaurs' families coming in from Europe and stuff like that. What I want to give people is a general sense of how we know what we know about the Earth's history. There is unfortunately a growing movement to deny observable fact and reality in our culture. This is not good because historically people who deny common sense observable stuff are dangerous or just generally difficult to deal with people. A lot of this stuff, as we discussed, a lot of it's like basic observation and comparison. A lot of geology is just looking at the rock and going like, oh, well, that rock's made out of tiny little sand grains in this interesting sloping strata that looks just like the layers of a sand dune, and we're just comparing the rock to what's going on in modern times, and it's very clear when you start mapping all these layers of rock out that there's a shit ton of incredibly diverse Earth history going back an incredibly long period of time, and it tells us a lot about how our planet works and how life on this planet works. And that, I think I don't expect everybody to get like all like into it like some of us do. But I think it's good for people to have a general sense of just how observational natural sciences work. Which kind of brings me to my next takeaway, which is, it's a little more esoteric, but bear with me. Consider that these animals were just trudging through the muck of life, oblivious to the fact that they were leaving footprints behind them. They could have had no way of knowing that 112 million years later, a species of primate would evolve that would actually analyze the sediment and look at their footprints and infer all this stuff about the history of the planet based on this thing they left behind by accident. And that should maybe give us pause to consider the fact that maybe the natural state of most organisms is just to trudge through and try and survive without really paying attention to what we're leaving behind us. These organisms are fucking gone. None of these animals will ever get cloned. We don't even have bones of most of them. And yet the story that they left behind tells us about this intimate interaction between climate and biodiversity and what an environment can support when various resources are available to the living things within that. And I think that maybe we need to look at dinosaur footprints and see ourselves there and go, holy shit, we as a species and as a culture, our own survival actually depends on breaking that natural state of not giving a shit about what we leave behind us, because we have this weird ability to look at the planet that we rose from and go, oh shit, that's how this works. I'm doing that to this. And I think we really need, as a species, to start thinking in terms of, okay, what am I leaving behind me? What footprints am I leaving? And what will those say about our species and culture to future hyper-intelligent life forms that study our fossil record? But more importantly, just generally, pay attention. We need to pay attention to what we're doing, because the footprints our species are leaving are way fucking bigger than these footprints. We're leaving vast swaths of rainforest decimated for palm oil and toilet paper, and there's a section of the Pacific Ocean that's so full of degraded plastic that the things that we rely on for survival, the plankton that make our oxygen, can't even live in that whole section of the ocean. So I think that's a takeaway that hopefully everybody can access, regardless of whether or not you give a shit about dinosaurs. So thank you all for listening. You've been an awesome audience. I don't mean to end on a bad note. Can I get a quick round of applause for the paleontologists? Rebecca Hunt Foster, John Foster, Jim Kirkland, Ken Carpenter, Matt Wadle, Darren Temke, Sean Cordes, Elizabeth Montgomery, Lee Shanton, and the Utah Friends of Paleontology. I couldn't have done this without them. They're awesome. And if you want to support my art, I got art for sale in the back, and I'm on the social medias and Patreon and all that. Thank you for listening. Sorry, Bart. No time for questions, right?
Give it up one more time, Brian Eng. That was awesome. You are going to be hanging out by the merch table, right? So we're going to take a 10-minute intermission. If you have questions, talk to Brian in the back, grab a beer, meet your neighbors. We'll be back. Thank you.